Good morning, y'all. So, continuing with our lessons, we're going to talk about area of compound figures and then parallelograms. Compound figures kind of follow the process that we did yesterday with rectangles and squares. A compound figure just means that it's made up of multiple different shapes. So, there's two possible ways to go about this approach. The first one is the split apart and then add up method here. So this is my diagram. I've got this like L-shaped rectangular figure. And when we say split it apart, what I mean there is that I can cut this shape kind of across the middle there and then create two different shapes. So one of my shapes here is a rectangle, kind of like that. And then the other shape is a longer rectangle. And I just have split apart the two different shapes. So this one here, it's got dimensions of 3 and 5 if we follow from the sides here, 3 and 5. And then we'll have to figure out the length of this bottom one. If I add up the sides, it would be 7. So that gives me dimensions here. And then this one's going to be 4 off the side. So it'd be 4 and 7 here. Now, how I approach this, I always label it like A1, A2, depending on how many different figures you have within that compound figure. Makes it a little bit easier to add some annotation to it. So A1, the area would be length times width, so 3 times 5. So A1 is going to be 15. And then for A2, again, length times width, so 4 times 7. So A2 is equal to 28. And then my total area would be equal to A1 plus A2, which is equal to 15 plus 28. So my area is equal to 43 units, that look like an A, units squared. So that's the split apart method. Again, you could have actually approached it if you wanted to cut it down the side here as well. It doesn't really matter, but what I would recommend is only do one cut if you can create two different shapes. I wouldn't create 3 shapes from this. The next method that we could do for compound figures is the cutout method. So that's if you have one larger shape and then a smaller shape on the inside of it. So notice here I've got this larger rectangle. This kind of looks like a picture frame. And then I've got this smaller rectangle on the inside of it. So this cutout method, how we're going to find the area is we're going to do the area of the big minus the area of the small. So I'm going to redraw my small over here. So this is small. And then my small has dimensions. The width here, this would be 8 minus 1 minus 1, which is 6. And the reason that it's minus 1 is that this has a width of 1 on each side of this frame edge, I guess we'll call it. And then for the length down at the bottom, that would be 12 minus 2, which is 8. So the area of the small is equal to 6 times 8. So area of small is 48. Now, let's look at the area of the big. That one's a little bit easier because we see what our dimensions already are, 8 and 12 here. So that's going to be 8 times 12. So area of the big is equal to 96. So the area would be equal to area of big minus area of small, which is equal to 96 minus 48. So our area is equal to 48 units squared. So again, that's how if you have two figures one inside of another, you can take the bigger one and subtract out the smaller one. So those are compound figures, just two different ways that we can find area. The last thing that I want to talk about in this video is parallelograms. So parallelograms have two dimensions, base and height. The height, and this will be important, the height is perpendicular distance between two sides. So that's kind of a key here, is that the height has to be perpendicular to two different sides. And then your base is whatever side is perpendicular to the height. So again, it comes back to that perpendicular statement. So your height and your base should be perpendicular to each other. The formula that we need for this is that area is equal to base times height. It's pretty similar actually to our formula for a rectangle, because think, a parallelogram is just a rectangle that's kind of pushed sideways a little bit. It's leaning to one side versus the other. So let's look at two examples here of our area. So let's find the area of the parallelogram here that I'll draw. So I'm going to draw one kind of like this. And then I've got this line going up that way. I'll add a right angle there. I'll add that 10 there. Here's 8 inches going up along the side. And here's 12 inches going along the inner. Now, you have to be careful when you're identifying what's your height and what's your base here. My height, again, is going to be perpendicular to two different sides. So here, you'll see that the dotted line is actually going to be our height. So if we're using that formula where area is equal to base times height, my height is going to be 12. My base has to be the side that is perpendicular to the height. So our base is actually 8, even though it's not the one that's the bottom. So that is a note that I'm going to make here, is that you have to be careful, because base does not mean bottom. So it's not that the base is always the bottom of your figure, it's that the base is perpendicular to your height. So let's continue this work here. So our area, if our base is 8 and our height is 12, it's going to be 8 times 12. So our area turns out to be 96 inches squared. Pretty straightforward. We'll look at another example here. So I'm going to draw a line down the middle here, split these two apart. So we are going to find the area of the parallelogram. Now this one's going to have a little bit more work attached to it, just because we got to add something to it. So here's my parallelogram, not the greatest looking thing, but it works. So I'm going to add this right triangle off to the side here. Let's label our sides here. We've got 4, 5. I'm going to say that this length here is 8. This little segment here is P. So that's what I'm going to add to my figure here. Now, as we're looking at this shape, I threw in this extra variable of P because we need that entire length for our base. So remember, our base is perpendicular to our height. Our height here is going to be 4 because that's the perpendicular side here. But then our base is going to be 8 plus P, but I need to figure out what P is first. So off to the side over here, we could figure it out because this is a right triangle. So I'm going to use Pythagorean theorem. So 4 squared plus P squared is equal to 5 squared. So 16 plus p squared is equal to 25. So that means p squared is equal to 9, where p is equal to 3. So that means that if p is equal to 3 here, for the entire side over here, that would be 11, because our base is going to be equal to 8 plus 3 when you add those sides up. So it gives you 11. So using that here, we have base times height. So our area is equal to 11 times 4. So our area is equal to 44 units squared. Now that little u that we threw in there, that stands for units. If you don't have a unit of measurement, so if it's not inches, meters, centimeters, whatever it might be for measurement, if there isn't one given to you, you still have to define it as being some unit. So we say that it's going to be units squared. So quick introductory to area of compound figure and then area of parallelograms. We will cover this again in class the next time that I see you, so make sure you copy down those notes in your notebook. Hit the like and subscribe button for the YouTube video here.